this image histogram, I mean, you specify a particular histogram and then convert the given image into that kind of a histogram. So if I mean, and then finally you adjust the pixel values, bring back the image to the original um, image pixel, right? So if you can do that, we're actually doing some kind of image matching or histogram matching or histogram specification. So of course, this is how you compute, for example, the histogram. So or probability of a particular image taking a particular value. For example, I of UV, probability that the image image takes a value called I over U and V is number of pixels with the value I divided by total. This is a simple definition of a probability. I'm not going into the details. But however, the histogram specifications is that we need to specify a particular histogram, convert all your input A to A dash, then you can plot the modified A dash and see whether these pixels are giving two good results, right? So another important this thing is matching histograms. So you have a reference histogram and you wanted to modify this original histogram to this, right? So this is what is called as histogram matching. Given two images A and B, you want to make their intensity profiles look as similar as possible. So you have to simply match their cumulative histograms. You know how to plot a cumulative histogram. Given a histogram, you simply have increasing intensities, right? So when you have increasing intensities of A and B, then you are trying to match the values of the pixel at every intensity and its corresponding probability of presence. So this is possible, adjusting the cumulative histograms, right? I'm not going to the detail, but some of them can be modified. So given a given an image, so histogram equalization, histogram matching will help you to improve the image quality. So